So good morning or good afternoon, everyone. Depends on where you are. I would like to welcome you to the OPWA's Right-of-Way Management Month. My name is Mark Cavanaugh with T2 Utility Engineers, also the current acting secretary of the OPWA's Right-of-Way Committee. I'd like to welcome everybody. I think we got a great presentation for you today. A little bit of information though. The Ontario Public Works Association Right-of-Way Management Committee is pleased to announce that going forward, it will be linking arms with the American Society of Civil Engineers, Utility Engineering and Survey Institute, known as UESI. Ontario chapter to co-host the annual Right-of-Way Management Conference. For those of you who may not be familiar with the UESI initiative, I invite Kate Pang to briefly speak on who they are and why the linked arms to co-host the 2020 Right-of-Way Management webinar series and future conferences. Kate?
Thanks, Mark. Hi, everyone. I hope everyone can hear me clearly. I know that sometimes we all have issues with Zoom, but hopefully today is one of those days it all goes well. So my name is Kate. I am a representative from the Utility Engineering and Survey Institute Ontario chapter. We are affiliated as a branch of the American Society of Civil Engineers. There are two chapters in Canada. We have Eastern chapter, that's Ontario, Quebec, and everything to the east. And we also have a Western chapter, that's BC, Alberta, and Saskatchewan. And we have members all across the board. Aside from being responsible from the engineering standard ASC 3802, as most of you should know, is the standard guidelines for the collection and depiction of existing SU data. UESI's vision is to be the worldwide leader in generating products, services, and promoting excellence for utility infrastructure, engineering, and survey. The Ontario chapter was founded, we founded it in December 2016, and UESI Ontario was the first Canadian chapter within the UESI. We've done a lot of growth since 2018, and we're always encouraging new members to join. And we're really excited this year to be a co-sponsor for the 2020 Right-of-Way Management Conference and beyond. We felt that this was a really great opportunity for us to join with the OPWA Right-of-Way Management Committee, because UESI has very similar goals and objective. We really want to increase our exposure to members in Ontario and the chapters across Canada and the US. We want to offer mentorship to young professionals in the industry and get them involved at a younger age. We want to strengthen our already established successful conference, and we want to thank you guys at the OPWA and the Right-of-Way Management Committee for allowing us to join with you guys. And that being said, I will let Mark take the microphone back and introduce our speaker for today. Thanks so much, guys.
Great. Thanks, Kate. Prior to starting today's webinar, just a few housekeeping items to go over. All attendees are going to be on mute throughout the webinar to eliminate background noises. There will be a question and answer period at the end of the presentation if time permits. So in the interim, throughout the presentation, please enter any questions you have into the Q&A tab, and just please do not use the chat tab. This webinar is also eligible for the OASET CPD program as a partial 1-hour fulfillment of the full day informal course, self-directed study. A proof of registration and a short summary of what you learned will need to be submitted to OASET for the webinar to qualify towards your CPD. Today's webinar is Digital Twin and Geographic Information System, which is presented by Kris Philpott of PlanView. Kris has 17 years of experience gained through managing and implementing solutions for electric, gas, municipal, and telecommunication infrastructure owners throughout North America. As a co-founder of PlanView USL, Kris was instrumental in developing a strong understanding on how mapping can improve business efficiencies through digital twin innovation. If you're interested in learning more about Kris's career, please go to the webinar registration section at rightofwaymanagement.ca. Kris, the virtual stage is yours.
All right, thanks, Mark. Hope everyone is doing well today. I am going to switch the screen over here momentarily. Perfect. All right, so like Mark said, I'm going to be talking a bit about this concept of a digital twin today and how I think GIS is the foundation and how GIS really can help us implement this concept. But a couple things before we get started, right? So, right-of-way management, why are we here? It's really all about coming up with ideas and better ways to efficiently manage the right-of-way. And, one thing that is key, I think everyone would agree, is communication, right? So it comes down to how can all the stakeholders better communicate, share information, and just, be in the know. And that's one of the underlying kind of themes with what I'm talking about today, is how this concept of a digital twin and leveraging the spatial data that we already have in GIS can really be the foundation for that. So right away, when I talk about digital twin, it really is a virtual replica of a physical asset, which we've been doing for a long time. The one differentiator is it's not just like a drawing or scaled model. It connects the physical asset with the virtual asset through data points, through devices, through sensors and things like that. So I'm gonna go through and try to help explain that concept, tie it back to GIS and where we are today, how it applies to right-of-way management, the role of GIS, like I've mentioned, as the foundation. Talk a little bit about what's possible and try to have some fun along the way. And that's partly why the S is in brackets. If I can do one of these things today, maybe I'll achieve number 5. So before we get started on working through this, you've heard a little bit about me. I'd like to get an idea of who we have here, who's attending today. So I'm going to go ahead and pass along through the chat a link to a survey, and it's completely anonymous. So everyone should receive that through the chat. You can access that just by hovering over the bottom of your screen. You should be able to see that post from me. If you click that link, it's going to open up just a simple little form. I've listed out a few different organizations that each of you could be representing. So if you could click through there, just so we can get an idea of who's here today. On the screen, for your benefit, I'm listing out some of the professions in case you got to think twice about which one you want to click on. That's great. I can see many of you have already responded. Right now, exactly 50%, so 33 responses and 35 responses, just over 51% are representing municipalities. And I should be able to just bring this over here for a minute. So there's a breakdown of who we have here. So we have some representation mainly from municipalities. We also have some representing Sioux, which is great. Some telecom from the GIS side. It's good. We got a good mix here. That's great. Thank you. Appreciate that. All right. So a little bit more about myself. For those of you who know me, I don't know if you can see on the little screen or not, but this is my official avatar. Created this a few years ago, and what I found during the pandemic. This is linked to my profile. So many times when I join, whether it's a Google Meet or a Zoom meeting, Microsoft Team meeting, whatever it is, this picture comes up as my profile whenever I'm not in the mood for turning on my camera. And people have come to expect it. And the other day I turned on my camera and kind of kind of got a couple boos. I think people are used to seeing that picture. They actually prefer it. So that is not my digital twin, though. That's not where I'm going with this presentation. Now, in preparation, I've seen quite a few webinars over the last several months while we've been home, and one of the things I always do, I always Google the presenter just so I can see a little bit about them. So I figured I'll put myself in your shoes, and I Googled my name, and I was actually pretty surprised. I found a couple other Kris Philpotts with the same spelling. So I just want to make sure, for those of you that are Googling me, I am not at Potsy_101 on Instagram. Although we do have some things in common, and he does seem like a great guy. Just to be clear there, any of the stuff he posts is not me. And I'm definitely not Wagon85 on Pinterest, although we do seem to have a lot of the same interests. I noticed he's recently most likely renovated his entire house, including his laundry room, which I'm in the middle of right now. So I think I grabbed a couple of his pins so I can steal some ideas. But yeah, those are not me, and they're not my digital twins. All right, so next survey question for everyone, just to gauge, everyone's level of knowledge or understanding of this whole concept of digital twin. So I'm sending out another chat message here with a link to another survey, and it's really just to gauge where's everyone's level of understanding when we talk about digital twin. So if you guys can go ahead and click on that, give a couple quick answers. This will just help me, so I'm not jumping forward too quickly, and I'll try to pace myself accordingly. And we can see these results coming in here, which is pretty nice. We got a pretty good mix here. Got a few people. It sounds like it's fairly new. About 30 responses so far, so that's good. I'll keep that in mind as I'm stepping through. Appreciate that. All right, let's get into this digital twin concept. So a little bit about the history. I'll be honest, I wouldn't have, if I didn't do some research before this, I wouldn't have known that it dates back almost 20 years when Michael Greaves really coined this term digital twin. Back in 2002, and he was really more focused on manufacturing and product lifecycle management with this idea. But really, this image here, I think, kind of captures what he was visioning. And we see this 3D model of some equipment, and in his world, that it could be anything on a manufacturing line, and the product itself as it's going through the manufacturing process. But it's more than just the 3D drawing or the 3D render. It's having systems that can model the real physical asset, and being able to bring in information and data in real time to understand the current status or condition of that physical asset, and what exactly is it doing. So one that we can wrap our head around quite easy would be temperature sensors. So imagine a piece of equipment that's operating and in a remote location, and you pull in some information about the temperature at key locations, so you can monitor it, right? You understand how it's operating. Maybe you know the voltage and current draw, and whatever widgets it's helping make. You're tracking the efficiencies, inputs versus outputs, and so that's really the concept, I think, that he was going for. And some people might be thinking, well, that's nothing new. We do that we've been doing that for years. And it's true, there's SCADA systems both in manufacturing and in electrical, telecom, and distribution systems that allow us to do that and simulate our network. One of the big differences, though, with this concept of digital twin is it's much more than just simulating those data points. It really is having that full scale model and being able to really depict every detail about that asset, and I think more importantly, the environment around it and how other things and people and processes can impact that asset. So bringing it, more into our world, something that is more relevant to what we're talking about. This is a little diagram. I adapted it just slightly from an article that was actually written from Greaves back in 2002. So the concept here is we've got our real world physical asset. In this case, it's a traffic light. And then we have our virtual asset, right? So that in and of itself really is nothing new. Of course, we have our 3D models and renditions of when we do our designs, but we also would model those assets in a GIS system or in a SCADA system. In most cases, it's a point on the map that says, here's where your traffic signal is located, and we have some information about that, when it was installed, maybe even the last condition assessment. And if we have some technology like a SCADA system, we are receiving real-time information. What's the current state of that traffic signal? Tracking red, green, yellow, red, and you can visualize and simulate that on a screen. I think where digital twin is taking it is beyond that sort of 2D representation. So we have our 3D representation, and we're pulling information back in outside of just the asset itself. So maybe we have some real-time information coming in on traffic flow. Maybe we have weather information. And so we're really trying to build out that full-scale model of the real world so that we can build and simulate our processes in the virtual world and drive what we do from decisions down to discrete steps out in the field. We can do it all virtually. So just coming back to the fundamentals of digital twin, there's really kind of three concepts that best describe it. One is the physical asset itself, and I think this example here of a satellite, albeit more extreme than what we would deal with in our world. It's a good example because obviously you can't do a site check or a field visit on a satellite very easily. Not to say we can do that with all of our assets that we manage either. There's a lot of factors and a lot of costs to that. So physical asset in this case is satellite. So what we would do in the digital or virtual world is fully model that every component, every discrete sensor and input point, so that we can best model the current condition, whatever data endpoints we can collect on that asset in real time. So to the best of our ability, we can see what's going on. So we've got the physical, we got the virtual, and the third component is the connections between the two. And that's not always, it doesn't have to be one way, right? That doesn't need to just be the sensors and inputs and that are helping us to visualize. It can also allow us to simulate and model things on the virtual side that could drive outputs that occur on the physical asset as well. So it's really merging those two things together and allowing us to make decisions sitting behind a desk and actually carry out those tasks without ever having to go see the physical asset. So, applying that to our world, There's many different applications to the physical assets that many of us manage. Whether it's from the municipal side, water, wastewater, the gas side, actually controlling valves remotely, or the electric telecom side, controlling switches remotely, which again, we do today, but digital twin kind of takes it to that next level where we're adding in more information beyond just the networks themselves. I think this next image, which I borrowed from Microsoft, really helps bring it all together and tie it back to our worlds, so to speak. So I'm just going to pause it here for a minute, and I know it's not necessarily the cleanest image here, so I'll try to describe it as best I can. But they're painting a picture of this digital twin model that I liken this to the smart city concept, and it's really about marrying together all of our physical assets out in the field to our digital replications back in the office through all of these various data points, right? So this covers off down to smart grid, which here in Ontario we're making huge strides. The LDCs have made huge strides in that area for many years, where we have intelligent devices out in the field, right down to smart meters, passing information back in near real time, so we can simulate the electric network. So we're doing that today. How does digital twin change that? I think it's about being able to share and collaborate, right? What additional benefits beyond managing the network could, say, the smart grid data or the smart meters be able to provide when we look at that bigger picture? And so, tying it back to those traffic lights, an outage can occur. The electric network, could be self-healing, could be self-reporting. The local utility knows about it, but what would be nice in this digital world model is that external resources would be able to get an understanding for when those events occur. And then how does that tie into other things that might be happening? So with the traffic lights could be impacted, therefore, traffic control could be impacted. And as you kind of go down through this model, we start to see how everything else can be interrelated. And in the digital twin world, we'd be able to share all that information and collectively make more informed decisions on a daily basis. Just kind of show another example of this concept tied to a remote asset, right? So not necessarily easy to get in and do an inspection on a windmill. So the concept here is not only do we know, in a GIS system where your windmills might be and maybe what their outputs are, but with the digital twin concept, we would model, every component and pull back information, real-time information about what's going on. And maybe we can start to leverage that data and predict failures, predict more improved maintenance schedules, all driven out of our digital world environment, and streamline the whole process of how we maintain our assets. And I think this example could be replaced with any of our physical assets. It's just being at a remote location, you can really make the business case for why there could be value in this. All right, so now I'm going to tie it all back here now and really talk about how GIS can be added into this concept, or sorry, not added in. Maybe it's the other way around. Digital twin can be plugged in on top of GIS, right? So GIS becomes kind of the foundation. And the reason I believe that is, I've talked a bit about a little bit about where we are with GIS. I'm going to dive into that momentarily, but GIS already kind of provides that foundation. We know where our assets are, and in many cases we have our networks mapped out. We know where everything is. We know what's going on. It's all 2D for the most part. You know, some folks are moving towards 3D, and going to that level of detail where we're modeling every component of an asset. But for the most part, GIS isn't there yet. It's 2D. We know where things are. We know what they are. And so tying this concept of digital twin on top of that, I think, you know, forward thinking, there's a lot of benefits to how we can improve our right-of-way management, how we approach that, how we communicate. And so the next few slides, that's what I'm going to drill in on, is how GIS can be the foundation moving into the future for this digital twin concept. And I guess really, you know, even before that, how we can leverage what we already have in GIS, right? There's things we can do today before we go down this path of digital twin, which by the way, you know, is a concept. There's not necessarily off the shelf solutions that any of us can just plug in and solve all of our problems with, because it's very data intensive. And you know, we all know that even the GIS systems, the technology has advanced, and we're, for the most part, catching up with data, right? We're always trying to do better with reflecting reflecting what is out in the field and modeling that in our GIS. So let's dive in. Let's look at where GIS is today. So I think, you know, for the GIS folks that are here, for the folks that use this technology on a regular basis, is really nothing new, but just want to cover some of these basic ideas. So, you know, what does the GIS tell us today? And obviously everyone's at a different state, you know, path on the timeline of the evolution of their GIS. But, you know, fundamentally in the GIS, we know where things are, right? So we know where our assets are located for the most part, varying degrees of accuracy, and, you know, whether that's sub-centimeter or sub-meter or even just a schematic type representation. But generally speaking, most municipalities, most utilities know where their assets are, and they're mapped out in their GIS. And we know what they are, right? So to come back to that traffic light example, we know where it is, we know what it is, we know the type, when it was installed. We might even know the condition, right? So the last time there was an inspection on that asset. And so we've evolved this, and they continue to get better. And organizations use GIS every day to understand where and what their assets are, and starting to dive into, you know, on the asset management side, the condition, and really drive decisions, operational decisions on how best to manage your assets and coordinate your projects with others. Touch a little bit on, you know, the power of the, you know, modeling your network data in your GIS. So we've seen many customers model from you know, if it's gas, you know, from the source right down to the customer. You know, in whether it's water, telecom, electric, same idea, from generation or source right down to the customer level. Every component on that network is modeled and connected. And in the GIS, you can trace the network. So many customers are there today, and you tie in the power of SCADA, and we have a real-time virtual model of what's happening with our networks. This is nothing new. We have it today. We know real-time status of devices. We can overlay external environmental conditions like weather, temperature, and we can even simulate changes to our network, opening, closing switches. open and closing valves, see what the impact would be. We can do that all digitally today. Again, the difference is we're doing that in a 2D model, and we're really focused on just the network itself. And I think plugging this concept of digital twin, and it really is forward thinking. It's adding in the not just the information about the switch or the device or the network itself, but other factors, right? So where is that water main located, and what is nearby? What type of soil is nearby? If we have a sensor detecting that there's a leak, what's the potential impact to any other assets that might be around, whether that's buildings or roads and things like that, or other buried infrastructure or above ground infrastructure that could be impacted. So the digital twin concept really is just going above and beyond the individual network that we're modeling in the GIS. It's overlaying all the other pieces of information about the environment and other assets outside of even the utility that is modeling those assets, right? How each network can impact each other. I got to give a plug here to York Region and yorkmaps.ca. I think I've lost many hours playing around with some of their really neat maps online. There's a really good example that allows us to see sort of the present time, and you can easily swipe the map and see what any area in York Region looked like in 1970. And there's even a map, an interactive map that allows you to see some old paper records from the 1800s. Really neat tool. And the reason I bring it up is it touches on some of the things that digital twin talks about, with being able to model your assets as they age over time. And GIS already has the foundation to do that. And I think this is a really good example that illustrates what that looks like. And so if you do get a chance, I grew up in York Region, so I've already checked out where I've lived, where I grew up, the parks I played in, and what they looked like in 1970 compared to present day. And so it's just a really neat example to see how you can easily model changes like that, and how that can help make decisions moving forward, and how you can learn from the changes we've seen over the years. And that's obviously on a broad scale using aerial imagery. Same concept applies to our assets, right? Being able to see how certain assets are changed out over time. And if we get down to that digital twin type detail of every component, within an asset, and we're tracking all of those maintenance and condition assessments, the amount of data that we can collect and really start to drive how we manage those assets, the potential is really endless. I know that sounds cliche, but trying to stay on track here with my time. All right, so I'm going to talk now a little bit about getting a little bit sort of forward thinking. What are some of the areas we could start to implement today, even just with the 2D world of GIS or the 3D world that some folks are leveraging today, that are heading down this path of marrying the two together. So I want to talk a little bit about some of these, get some ideas going, and I just want to give everyone a heads up. What I'm going to do after I talk for the next 5 minutes or so here, I'm going to send out another survey and just kind of gauge where people, what you guys are thinking. Just, have I sparked any ideas? And I'm going to send that survey out. You guys can respond Yeah, we can kind of go down a couple paths of depending on what we hear back. So just want to give you guys that heads up so you can start imagining what the future could look like with this kind of technology. So I could have gone so many different directions with this topic here in terms of what some of the potentials are. So I've just picked a few here. I want to dive into to a couple from a high level perspective. So the first one, really, we talk about utility coordination and really want to tie that back to right-of-way management. We all know that investment upfront on utility coordination can save projects, save large infrastructure projects, large amounts of data, large amounts of money and time. Right? We know that a little bit of coordination up front really helps the design, streamlines the construction. That's a given. So what does GIS and this digital twin idea add to that? I think on the communication side, there's real opportunities to I guess improve on the communication, right? So today, a lot of that utility coordination is being done, we'll call it at a very technical level. Drawings are very quite technical, in various CAD formats. You're looking at 2D, you're looking at 3D representations, and those conversations are taking place at a very technical level. I've seen some examples of construction projects where the idea of digital twin was leveraged, and it broadens that the folks that are participating in those conversations from the purely technical to a larger audience. And so the examples I've seen with digital twin are actually quite impressive, and using augmented reality and virtual reality to be able to visualize a building and how it fits into the community and the surroundings. And when you can visualize that, it allows us to look at it slightly different and beyond that core technical team that know and understand those detailed utility coordination drawings. And now we can have project managers and even bring in senior level executives that maybe don't have that detailed understanding of those drawings, and they're seeing a 3D representation of a proposed project, proposed infrastructure, which again, we can do that today without this digital twin concept. But I think it's everything we've done today is building towards this concept. So how does digital twin help with that? It's not only the 3D model of what's proposed, but we can see the existing as well, and not just as a static representation, right? So imagine we see the proposed infrastructure, and we can see the existing infrastructure, and we can see the condition and what it's being used for, the current status, and really gain some really good insight into how best to go about implementing that new project. Think about it, if you had this perfect virtual environment where you could simulate an entire project, you'd be able to see what is the impact of relocating an existing gas main, right? What customers are going to be impacted downstream? At what point is it more beneficial to keep that in place and work around it versus doing a relocation and having that interruption? The other thing in this, in this virtual world or this digital twin model, you'd be able to do is simulate the actual project itself, simulate the construction, simulate the scheduling of all the resources that need to be on site, and really you know, from the comfort, well, these days, the comfort of your own home, sitting behind a screen, really get an idea for what that project is going to entail. So taking it from concept on paper to being able to see it, you know, carried out in front of you on the screen in this virtual environment, and then go back and tweak. You know, maybe you can tweak the design, maybe you can tweak the schedule and the whole process, just based on what you learn, seeing it, stepping through those processes through that virtual environment. So I think now I'm going to move forward and send out this next survey and see about getting some of your feedback, where you guys think there could be opportunities to leverage this concept, or even just leverage GIS today. I think, you know, on that note, while you guys receive that and plug in some information, I'll just speak a little bit about how even today I'm seeing GIS used more and more, but I think we could all leverage some of the data we have at our fingertips today, and it's a real easy example of tying to utility coordination is just understanding where everyone has projects, right? So there's some really good examples that different municipalities have online. Toronto has a really nice tool that maps out capital infrastructure projects from many different utilities. And so you can zoom into any location and see that there's a project scheduled for 6 months from now or a year from now. And, you know, it's coming back to that whole communication piece. Now that's one area in the province. And I think, you know, if we were to leverage that concept on a broader scale, we don't necessarily need digital twin. We don't need it to be 3D. We could just utilize what's at our fingertips today. If we mapped out all of our planned infrastructure work, all capital projects, even maintenance projects, because, you know, you've got overlapping crews. You might have a large scale project and another crew is coming out something completely unrelated to do maintenance on a project, and now you've got, you know, vehicles overlapping and crews getting in each other's way. In this, you know, forward thinking, you know, collaborative environment, we would have insight into all those different initiatives. Even being able to see where all excavations are planned, right? So we know, you know, all requests for you know, call before you dig through Ontario One Call, it's all streamlined through one place. But, you know, just being able to visually see where all of those upcoming excavations are going to be occurring and how they interrelate to capital projects, maintenance, even you know, private projects as well, because they can have an impact on projects going on in the right of way, just due to overlap. So that's something that we have today that we absolutely could leverage. Many organizations monitor and track that internally. They know where their projects are. They've already mapped it out on the GIS, and I think the opportunity is just bringing that all together. And again, that's, you know, call it phase one of moving towards this whole concept of a full digital twin environment of our world. So while I've got a few responses coming in here, a couple good points here. I'll just scroll through and find a couple we can talk about. So yeah, definitely a key one: repository of all underground utilities, right? And I think today it's I don't want to say it exists, but you know, each utility, each infrastructure owner is working towards that, right? Really mapping out and understanding where their infrastructure is. And I think the opportunity is you know, how do we bring that all together? And that's really what this is about, is in this digital twin world, it's bringing all that data together and collaborating. Yeah, point here, project management. I think that's what I was trying to touch on specifically, with just overlaying you know, where everyone is and where work is happening, what's scheduled. A good point here, you know, obviously required to really get to this is integration of the CAD data into GIS, right? So we talk about those 3D models. We talk about you know, all that work that's done at the engineering stage, typically in CAD, you know, getting that into the GIS, that's also kind of part of the whole foundation of moving towards this whole environment, is that we need to have that workflow in place that we can, you know, we can take those 3D models and they just evolve into the digital twin of each asset. Yeah, another good one here, just integration of public and private utility data. Again, it's all about collaboration. Yeah, how we could help with road improvements and relocations. Yeah, so really appreciate that. Some really good feedback. Now I got to confess, this whole little graphic and animation, I came up with this idea last night, and I think it was like one of those times where in my mind this whole thing was going to be animated, but I quickly realized my limitations with the software and my limitations to animating things. So this is about as far as I could take it. What I'm really going for with this is you know, maybe a little extreme, but here we see this, you know, on this road, a lot of things going on, right? So just trying to paint that picture of you know, things that could be happening in any municipality, and how sharing information and being able to understand you know, cross utility what's going on could really help us. So I'll try to explain where I was going with this. Just this concept here. So, you know, whatever this is, there's a damage to an asset, and you know, I'm implying here that this is a damage, you know, during an excavation. But you know, it doesn't even have to be. So just to tie it back to digital twin, let's assume that there's a water main here that has a leak buried underground, obviously. And there's some network sensors that are tracking information, and so we could probably predict that there's a leak somewhere on that water main. And in our virtual world, we you know, that would be identified as a known leak, and we would schedule, you know, when that was going to get dug up and fixed. So you know, a work order gets generated and that gets planned. But how does that impact other projects that are already scheduled in the right of way, maybe even a large scale project that might be 2 years away, that might already have plans to relocate that water main, right? So are there opportunities to be able to make a decision at that time? You know, do we just repair this, or you know, is there an opportunity to do something else to benefit that project that's 2 years out? You know, I think we've probably all seen projects where you know, a road, you know, nice new road gets paved, and you know, that first road cut that happens afterwards, it's kind of like, it's too bad there wasn't some foresight or something to prevent that, right? Could we have predicted that you know, we needed to do this road cut? And sometimes you can't, obviously, but if there are opportunities to collaborate and get more done when we're digging up the road, we want to take advantage of that. Another item on here is with the gas leak, right? So in the gas distribution world, there's known locations of leaks, and they get prioritized and resolved over time. And a really good example that I was involved with a few years back is modeling those known gas leaks and prioritizing them based on location. And we did this just using GIS, but I think it can be, in this, with a digital twin of the full environment, it could be taken to another level. But even in GIS, some things we do know, right? We know, the location of where that gas leak is. Maybe we know, on that same line, there's multiple gas leaks, so that might increase the priority of when that needs to get repaired. But if we look beyond that, maybe we know, what the area, what's around the community, that might some environmental factors that might change our mind and make that a higher priority. But if we had a real good collaborative approach, and with some real-time information, maybe we could take an opportunity, because there might be another utility or municipality. There could be some project going on out in the field that is exposing that gas main. We might be able to collaborate, perform the work at the same time, take advantage of that opportunity. And an easy one to visualize would be like road resurfacing or replacement, right? So if the gas utility knows of some leaks that they plan to get to in 6 months, if they knew that the municipality was resurfacing that road and there was going to be a moratorium on that road, and they wouldn't be able to dig up and cut up the road to get to that gas main, they would want to get in there beforehand. So that's an easy example of how we can collaborate. The other thing I was going for here is just something seemingly unrelated to the right of way. A homeowner, let's say, putting a pool in their front yard, as this picture shows. Maybe nothing to do with the right of way, but they're going to have crews coming in. They're going to have a big cement truck possibly blocking the road, and perhaps there's a major infrastructure project happening at the same time. So how could we overlay, or how could we get insight into that? I mentioned earlier, I think the locates are a good example. Each utility would receive that locate ahead of time that this homeowner is going to put in a pool. So it's really about tying all that information about any given location into this digital environment and being able to see everything going on in that location. So some work order on a street that's managed in a non-map environment today, it'd be really hard to gain insight into a locate 100 meters away. But on a map, or in a virtual digital twin environment, those two things suddenly became related simply because of the location. And then I threw the fire truck in here because it just takes us to one step beyond our sort of focus on infrastructure, and that is when we're doing these projects, when we're ripping up a road, what's the impact to the public, right? And it's just another piece of information that could benefit the public, sharing not only that there's a proposed project, but more details on the status of that project in terms of lane closures, interruptions to traffic. And I've seen a lot of really good progress on this. It doesn't have to be full digital twin to take advantage of that. It can be, just overlaying on a simple map like Google Maps, but being able to share that information in more real time could help, emergency services and just overall public. All right. In the interest of time, I'm going to plug through here because we are coming up on 12:55. Really appreciate the survey responses and the feedback received from everybody. My contact information, like Mark mentioned at the start, is on the website. It's here on my digital twin business card. If you guys want to jot that down, stay connected. Some really good responses here with some interesting ideas. Be happy to discuss with anyone if you guys want to reach out. But really appreciate everyone joining today and appreciate the feedback.
Thanks, Kris, for the presentation. There is one question that we have posted, if you wouldn't mind answering it. I'll read it out to you here, and I'll remind everybody that if you have other questions, feel free to type them into the Q&A, and we'll get this answered. So, Kris, are there standards governing the development or components of a digital twin?
I would say not covering our sort of our world on the infrastructure side of things. There definitely is when we talk about CAD standards and even into GIS and some of the 3D standards, but in terms of digital twin concept, not to my knowledge. Okay.
That is the only current question that we had. Actually, Lori, we do have a quick poll that we'd like to run from the OPWA Right-of-Way Management Committee's perspective. Can we post that? All right. I'm not seeing it, to be honest with you, so hopefully that is posted. It may just be a viewing issue on my end. But I would like to move ahead and maybe share the final screen. So once again, Kris, thank you very much for your time. That was a great presentation, and I think maybe the lack of questions is because it's just a new concept. There's a ton of possibilities there that you went over. So I think you've got a ton of opportunity coming up in front of you. So I guess just thank you to all the attendees. What we'd like to do is just notify everybody that these presentations will be posted to the OPWA Right-of-Way Management Committee website, of course with permission from the presenters. And they'll be done so towards the end of the month or into early November. Just keep checking back to rightawaymanagement.ca. And we'd like to, of course, remind you of the next presentations that are coming up, which is next Tuesday, multi-channel GPR, applications for your project. That's presentation being done by Jamie Bradburn at T2. And then on Thursday next week, we have digging into late locate submissions. That's something that we all have issues with, trying to get projects going. So that's coming up next week. Make sure you go to rightawaymanagement.ca to learn more and sign up if you haven't already. Thank you, everyone. Enjoy your day.